My dear student, welcome to School of Fundamental Sciences, SOFS. I deliver some fundamental concepts of physics, chemistry and mathematics for JEE Main and JEE Advanced. It will give me great pleasure if you enjoy this concept. So let us start application of integration to evaluate area. First you see, we are discussing the displacement, yes, in terms of the area of the region bounded by velocity time graph with the t-axis. Now you see the displacement element dx equals to v dt. You know v is equal to dx dt. So dx equals to v dt is the displacement element during the time interval dt for the particle with velocity v. Now it is a velocity time graph. So what is the v dt? Please you see, if we consider the deep shaded strip, the v is the what? The height of the deep shaded strip, and dt is the what? Width of the deep shaded strip. So what is v dt? Area of the, it is sufficiently close to rectangle. Yes, approximately you can consider this trapezium. Trapezium is sufficiently close to rectangle because area of this rectangle plus area of this triangle, yes, equals to area of the rectangle, because the area of the triangle is very, very small with respect to area of the rectangle. So simply it can be considered to be a what? Rectangle. So its area is v dt. So the what is total displacement from the interval t is equal to ti to t is equal to tf. Now that is equal to delta x, our sim notation, is equal to integration of, because if we integrate this v dt, that is called displacement, from t is equal to ti to t is equal to tf, this deep shaded strip will move from ti to tf, thereby making this completely shaded zone, and area of this zone will be, you see what, come here. So total displacement of the particle from the time interval ti to tf is equal to delta x, equal to integration of dx from xi to xf is equal to, what is dx? v dt from t is equal to ti to t is equal to tf. So the v dt is the what? Area of the deep shaded strip, and it will move from t is equal to ti to t is equal to tf. So we will have, this will give the what? Total area of the shaded region. The total area of the shaded region enclosed by vt curve, t axis, and the two verticals line ti and tf. So the area of the shaded region, that is the area of the region enclosed by vt graph with the t axis in vt graph, where v along the vertical axis, t along the horizontal axis, will give the total displacement of the particle from t initial to t final. Now one thing you remember, that to compute area, that dt is always a positive quantity, always will move from left to right. So initial will be always smaller and the final will be always larger. So dt will be always positive. Now if the curve lies in the first quadrant and second quadrant, v also positive. So v dt positive. So when the curve lies in the first quadrant and second quadrant, dt area always positive. Yes. And if the curve lies in the third quadrant and fourth quadrant, dt permanently positive. Be careful. Always you move from, to compute area, always move from lower end to higher end, that is along the increasing t. So dt permanently positive. So if the curve lies in the third quadrant and fourth quadrant, v is negative, but dt permanently positive. So v dt is a negative area. So when the curve lies in the third quadrant and fourth quadrant, area must be negative, because dt positive, v is negative. So v dt will be negative. Only we have some exception, particularly in thermodynamics. If you have a cyclic curve, then we have some deviation. When increasing dv positive, when increasing variable positive, when decreasing variable negative. But in general and in mathematics, this dt or dx along the horizontal axis will be always positive, and the vertical line, if lies above the horizontal axis, positive, so area will be positive. If it lies below the horizontal axis, so area will be negative, because the vertical height is negative, but dt is always positive, so area is negative. Now sample example 24. You see how to apply graphical concept to find the displacement of the particle between t is equal to 0 to t is equal to 3 seconds. The particle is moving along the x-axis with the law that is with the velocity v as a function of time t it is given. We have to find the displacement of the particle between t is equal to 0 to t is equal to 3 seconds. We will apply graphical concept as well as analytical concept. So first graphical concept. Now v is equal to, it is given. Obviously you know it is a straight line. Y is equal to mx plus c. It is a straight line. It is a straight line. So yes, we can draw the VT graph, that is a straight line graph from this law. How? Now you consider t is equal to 0. When t is equal to 0, v is equal to 10 meter per second. So when t is 0, v is equal to 10 meter per second. So we will have a point 0, 10 meter per second. When t is equal to 1 second, then v is equal to 0, this point. When t is equal to 1 second, v 0, this point. And when t is equal to 3 seconds, finally 3 seconds is given. When t is equal to 3 seconds, v is equal to minus 20 meter per second. So when t is equal to 3 seconds, v is equal to minus 20 meter per second. So this is the point where t is equal to 3 seconds, v is equal to minus 20 meter per second. So you see, above horizontal axis v positive, below horizontal axis v negative. Always for area calculation everywhere, this is the rule and concept, and this will be always positive. Now we are going to find the what? Total displacement. So the total displacement x equals to area of the shaded region. Already we have explained. Area enclosed by the VT curve with the t axis. So area of this triangle plus area of this triangle. So area of this triangle plus area of this triangle. So far as this triangle is concerned, half into, be careful, this final minus initial. Yes, to calculate delta or dt like that, always higher minus lower, final minus initial. So final is 1 second, minus initial is 0. Yes, into height, half into base is this, into height 10 meter per second, plus area of this triangle, half into, again, this will be always positive. So final 3 second, minus 1 second, always, right, minus left, always. Only some exception, particularly in thermodynamics, in physics, we will discuss. Or permanently, final minus initial, 3 second, minus 1 second. Into what? The minus 20 meter, for the height of the right angle triangle, minus 20 meter per second. So this is a negative area, this is a positive area. Automatically will be adjusted. So 5 meter minus 20 meter is equal to minus 15 meter answer. This is the required displacement. Then analytical method. You see, v is given, this law is given. Now velocity equals to, dx dt. So dx, step 1, differential equation is made. Now we have to separate the variable. Just transfer dt here, looks like cross multiplication. So dx equals this into dt. So step 2, variable separated. Now ready for integration. So integration dx, your integration, you can separately integrate or you can integrate totally. So totally integrated. So t is equal to 0, x equals to 0 given, and that we have chosen. And when t is equal to 3 seconds, x equals to s. S is the required displacement from the origin. So dx means, we know x, upper limit s minus 0, so simply s. In this case, 10 meter per second is taken out. Integration of dt means what? T minus 10 meter per second square taken out, t square by 2. So 2 and 10 cancel out, 5 meter per second square. Then put upper limit, this into 3 second minus 5 meter per second square, 3 second whole square, minus 0 because t0, 0, 0, minus 0, so no need to write. This is equal to minus 15 meters.